video, we will discuss about the caching strategies. So, yeah, so we know how caching dramatically reduces the latency for database queries. So, so there are some strategies to do such cachings. So, if we see here, first and most popular caching strategy is cache aside or lazy loading. So, when we say this, if you see here, the process of cache aside or lazy loading. So first we check the cache and find the key. If it is not present, we call it as a cache miss and we query the DB. So this is here I'm talking about reading. So we will read from the query and then we will store it in the cache and then we will this thing will be what we call it simultaneous. So after the querying the DB that will be sent to application also. So in the meantime it will all again be stored in the cache. So this is lazy loading. If we see write through from the name itself, we say it writes through cache. So here what happens is first app writes into cache and then it will sync with DB and then it acknowledges the app that the write is completed. Here this is a very important thing. So first app writes to cache and then it directly doesn't say that writing is completed. It then writes to DB and then the acknowledgement is sent. Now if we see about write behind or write back, what happens here is again here we will write in the cache first. But from after writing in the cache itself, we will send the acknowledgement to the app that the write is completed. And in the background, an asynchronous process will be running to sync this cache and DB. Like whatever write is written, that will be copied to DB. Now, if we see read through, what happens in the read through? It reads through cache. If in the cache it is not present, this cache loads from the DB and saves in the cache, and again it sends response to the app. So yeah, so if we see here, generally we have many caches. Let's say uh, one thing we see thing without cache. What happens? Every request hits the database. Database CPU will reach 80%, and we know that this is the very bad. We need to keep at least we need to keep at least 20% buffer, so it has reached its highest limit. And now response time, if we see, it will be very large, like 200, and limited to 1k requests per second. You understood it, right? See here, throughput is also decreasing. So if we see about cache, with cache, what happens here is it can scale up to million requests per second. In some cases, not here maybe. A million requests when we use distributed system might be possible. So yeah. So 90% of the requests hits cache, right? Database CPU is very less. Usage will be very less. And response time, if we see, it will be very less again, 1 to 5 milliseconds. And from this, with this, it can handle almost 50 to 100k requests per second. Obviously, it depends on the RAM and all those things, but here we are taking for a general device. Now, if we see cache latency for right, we have been talking about SSD. SSD is something like disk. So SSD read is generally 1 millisecond. So, but to for comparison, if we see the L1 cache read, it is 1 nanosecond, and L2 cache, it is 10 nanoseconds, and Redis cache, it is an in-memory cache, it is 0.5 millisecond. So here you can see that as we are going into cache, the latency is decreasing exponentially. So when we compare from SSD read to database query, it is like database query is 100 times late, and the network API call, yeah, it's around 100 to 500 milliseconds. This is what happens as we are going to increase the layers. Now, if we see uh, caching patterns, we have been discussing previously. So we can discuss what are pros and cons for each thing. If we see pros for cache aside, what happens? We will first we'll check the cache. If there is a cache miss, we will query the DB and we give the response, and eventually we will store it in the cache also. So what happens here is here the data is cached that which is actually used. You understand it, right? If a data is not used, it is immediately removed. Something you can understand it, right? And cache failure. Let's say if there is a cache failure, will it break the app? It doesn't break the app here because it queries from DB. Stale data. Let's say if the DB is updated while writing, what happens here? There might be the chance of stale data in the cache because the cache might not be updated immediately, and during that time if there is an request from the app, then that will be stale, right? So there is a chance of potential stale data. So now if we see about what about write through caching. So write through caching, what happens? First we write to cache and then we sync it with the DB and then we send the acknowledgement. So here cache is always consistent with DB and no stale data problem, right? See, whenever you query, always you will get data from the cache here. So it is always updated according to the writes. So no stale data. So if we see writes, first it needs to write to cache and then to DB. So DB is the like durable storage, right? So to write into that durable storage, it is taking longer time. And what if we, let's say we, for every write we are caching here, but we might not read that cache every for the whole lifetime also, some caches, some keys in the caches. So that is also one problem here. Now if we see right behind, what is right behind? First we will write to cache and then we acknowledge the app in the background that will be copied to DB. So what happens here? Writes are fastening up here, but there is one issue here. What is happening? Let's say in between cache is what we call it, cache has been compromised, or let's say it is crashed. Let's say that Redis server is crashed. What happens then? Write is acknowledged, but that doesn't reflect in the DB. So this is what we call data loss, and this is very very complex to implement, and this is generally used for write heavy workloads. And let's say when we what about read through, let's say you're having something, what do we need? Let's say you first let's see how it works. Read through happens like first we will read in the cache. If there is nothing in the cache, that cache again auto loads from the DB and saves the same data in the cache and also sends it to back to the app. So here what is happening? the read latency is increasing. If you see correctly, read latency is increasing, and cache library support is needed. Because see, cache inside the cache should have the support to query the DB, that thing. And yeah, and also in similarly DB also should have some cache library support. And if we see app code, app code will be simpler when compared to cache. So because cache will be obviously difficult, that will be like we generally see some third party frameworks, but app code is what developers write, so that will be simpler. We have been discussing all this, and whenever we talk about consistency, we have talked about read and write performances, but if we talk about consistency, the first one, cache aside or lazy loading, what happens to the consistency, eventual or strong? Obviously that is eventual consistency, because let's say app has been written to DB. Okay, app has been written to DB. What happens now? There should be some cache invalidation event handler that should write back to cache. Okay, that will write back to cache. You understood it, right? So here in this point of time, if there is any read request, that will read stale data in the cache. So this is what we call a chance of uh, yeah, potential chance. There is a that this is like there is a time to update the cache, right? That is what we call eventual consistency, and uh, that is what sometimes there might be wrong data. Now if we see about write through, it is obviously strong, because cache is always updated with correct data, and DB is always durable here. But if you see right behind in that thing, there is a potential data loss. You understood it, right? And that eventual consistency also is very, like, it's very bad here, consistency, if we compare, because whenever the cache is the cache already acknowledges the app. Here the DB, whenever the cache is broken, the DB might have data loss, and that is what and never you'll never gain again consistency. That's why here consistency is very bad. That is why cache servers play an important role here also. And if we see read through, what will happen here? Here consistency is correct only, and normal that depends actually on the how we implement the write. Most of the time that write is implemented same as cache aside, so we can go with eventual consistency here. And now, what to cache? What kind of things we need to cache? We can't cache everything, right? If you cache everything, then our server will crash. So if we see, first thing is session data, user info, authentication tokens. Like to get a faster login, we generally cache them instead of doing some data queries or like reading from the disk and all those stuff. And some computed results. Let's say some results need heavy computing power. We once they're computed, we try to cache them. And reference data like time, like country codes categories, and time zones for each country, something like that. And next one is API responses from external services. Let's say we are querying capital cities for some countries or states. What will happen? Let's say there is an API. Most of the time, this capital cities doesn't change frequently, right? They stay for years. So that kind of data. I said very vague example, but yeah, this is also how it works actually. So where to avoid caching? Highly changing data like stock market, stock prices, all these things, and rarely access data. Let's say you are not accessing some data, just don't cache it. Waste of memory. And don't try to what we call cache large blobs. Blobs kind of like very large files like videos and large files because we can use content delivery networks for those things. Content delivery networks are basically built for that purpose only. Here, blobs refer to binary large objects like video files and all those stuff. And also, just don't sensitive data, don't cache sensitive data like without proper security. And now comes major and most important. Without this, like caching is waste. Cache invalidation. So, like Phil Carlton, he said that there are only two hard things in computer science. One is cache invalidation and naming variables. So, yeah, that was a funny thing actually, and that is actually correct. Once we try to develop some things, we face that issues actually. First thing is TTL, cache invalidation method. It is very simple, time to live. So we will set it. Let's say if we set it as 5 minutes. So whenever a key is updated or entered into the cache, it will be removed or it will be invalidated from that cache after 5 minutes. Just like some expiry time. This is very simple to implement, and cleanup is like it's an automatic cleanup, but data can be stale. See, if we set only time to live and the data might have been already changed, if that is the only way to cache invalidation, then most of the time we get stale data, and that with the exact value of TTL so that we get maximum cache hits. That is actually difficult to find. So we need to do some hit and trial, but that is not very effective. So next thing is event based invalidation. This is like most accurate invalidation technique, but most costly invalidation technique. So delete the cache whenever the data changes. That's it. So let's say there are many keys. For every key or for every write, what we'll be having is like we'll have some event listener. So what happens is that whenever the data got changed in the database, it automatically gets deleted. It's and from this we never get any stale data because there are event listeners. But the drawbacks for this is like we need to track all the writes. For every write, we need to add some event listening, all this stuff. Complex with multiple caches, and that is yeah, obviously. Now, one more very simple, or we can't say it is simple, but good method. Actually, fast method, very fastest invalidation method. It is a bulk invalidation technique. What we do generally is like, let's say we are having some user profile data which is cached, and let's say user has updated his profile. So what we do here is, while caching them in the cache actually, for with those keys we actually add a tag or a version. And so whenever the user profile is updated, we change the version tag. So what happens at that time is like the whole old version tags gets invalidated. It is very easy and easy bulk invalidation technique. So this is what it is. But still, that old valid version, like old keys, still exist in the memory, and memory got wasted because here we are not deleting them right here. That is the issue here. And what? And multiple caches also, like it works very well, because it depends on the version tag, right? We can use what correct tags and we can make it easier, but the memory is the only issue. And this is how it is. We have covered like almost everything for this. So yeah, that's it for this video. Like we'll continue in the next video. Thank you.